Pradhan Saab, good morning. Could you hear me, Pradhan Saab?
Good morning, good morning.
Patel Saab, good morning.
Yes, good morning, sir. Good morning. How are you, sir?
I'm fine, thank you. Namaskar.
Namaskar, sir. Namaskar, Pradhan Saab.
Namaskar.
So,
Namaskar.
Namaskar, sir.
Surya Saab, could you hear me? Head Saab?
Yes, sir.
Hazardous, please start.
Good morning, sir. Good morning.
Morning.
Now it is in time. We can go ahead within 1 minute. Now it is there. It is time. I can go. Shall we start, sir?
Yeah, please.
Okay.
hazardous साहब ये जो शेयरिंग है ना वो थोड़ा सा एनेबल कर दीजिएगा हमारे लिए जब जरूरत होगी तब प्रेजेंटेशन के टाइम में आई वुड नीड
Not
इट
to worry. At the appropriate time, we'll get all the things, sir.
करेक्ट
Before
या
that, I will introduce your regarding the candidature, your brief CV. After that, I'll put you here. No problem. Not to worry,
Please.
sir.
राइट सर
Participants are less actually due to some technical problem was there. That's why it is there. Now they are increasing. Let's see for another few seconds, then we'll start it.
Sharing. Hazardous Saab, good morning. The sharing system is not enabled possibly.
I'll share it, no problem, sir, after some time. Okay, sir.
Okay. Thank you, sir.
Good morning, Surya Prakash Saab and Professor and Dr. Malay Pradhan Saab, and as well as our Dr. Patel, the Senior Executive Director from IFCO, as well as the other panelists and dear participants. It is very good morning to all of you and namaskar. Today's program we are going to start, and you might be aware that today we kept the webinar on challenges on management of chemical and industrial disaster. This is a very serious disaster, and quite oftenly it used to take place. Now in this serious topic, today we are in position to give some discussion and as well as some presentation on that. We are having two learned speakers on this subject. Now, before going to that, I'll say a few words about the introduction of the industrial and chemical disaster. A chemical hazard is a substance that has the potential to cause harm on human and other animals' life as well as health. Chemicals are widely used in the home and in many other places. Hazardous chemicals are substances that can cause adverse health effects such as poisoning, breathing problem, skin rashes, allergic reaction, allergic sensitization, cancer, and other health problems from the exposure. Many hazardous chemicals are also classified as dangerous. Various types of hazardous in chemical industry is there. In chemical hazard, handling of chemical jobs is directly related to the chemical hazard in the industry. Like that, biological hazard is there, physical hazard is there, safety hazard, ergonomic hazard, psychological hazard, all types of hazards are there. Some common ways a person may be exposed to the hazardous in chemicals that include water. And it is this exposure through the water can occur when people drink contaminated groundwater or surface water or accidentally ingest in while swimming or showering. Similarly, in soil or sediment as well as dust, it used to percolate. And in air pollution, through the air, the hazardous used to come, this chemical hazard, as well as through the food. That food, nutritious food we are taking, through that chemical particle and other things that used to cause some exposure, and it creates problem. The hazardous substance and sites are there. Nearly every activity leaves behind some kind of waste in the environment. Household create ordinary garbage, car, trucks, buses, different types of transports. It emits exhaust gases. While in operation, an industrial and manufacturing process create solid and hazardous waste. Some waste contain chemicals that are hazardous to the person as well as animals, different kinds of animals is there. The place where chemical originates is called the source. Chemicals can enter the environment from many different sources such as landfills, incinerator, tanks, drums, factories. The human exposure to hazard chemicals can occur in the source, or the chemical could move to a place from where people can come into contact with it. Chemicals can move through air, what I was telling, through air, soil, as well as water. Now, but I will say about few words about the industrial hazard. But industrial hazard may be defined as in many conditions produced by industries that may cause injury or death to personal or loss of product or property. Safety in simple terms means freedom from the occurrence of risk or injury as well as loss. The industrial hazard consists of different principal hazards are there. This is because the industries employs many different processes involving a wide range of different raw materials, intermediates, waste product, and final products. The hazards encounters are fire, explosion, toxic release, and environmental damage. Chemical industries nowadays are very much growing, and obviously it is going very fast. Major installations such as gas processing complexes, petroleum refineries, fertilizers, industries are processing 1,000 tons of hazardous chemicals every day, globally as well as nationally. Need for a large inventory of formidable as well as toxic material arises to meet the manufacturing demand. This is rapid growth in the use of hazardous chemicals in industry, and trade has brought about very significant increase in number of people, both worker and members of the general public, whose life could be endangered at any one time by an accident involving these chemicals. The release of hazardous chemicals is inevitable, irrespective of many safety precautions taken during design, construction, commission, and normal operation of any chemical processing unit. Therefore, various hazards, irrespective of the precautions taken at the installation at the commission site, it used to arises due to the different circumstances in the factory or in the environment, due to the natural some other disasters are there. Due to that also, that may affect the different kinds of disasters. Now, for that, our experts will tell you, they will enlighten about the causes and various things. Now, the objective of the program will be of chemical and industrial hazard. That is why the chemical hazards are important. Second, how can we prevent chemical hazards? This is one of the important things in our objective, how we can prevent. And what are the objective of chemical safety? Similarly, for the industry, what are the precautionary measures we can take for industrial safety. So on this, and before hand over to our speaker, the keynote address will be given by our professor, head of division, Professor Surya Prakash. Before hand over to him, I will make familiar about him, Professor Surya Prakash. I will say a few words about him. I hope it is visible, this slide, sir.
Yes, sir.
Visible,
Visible, sir.
Yes, sir. Now,
Visible.
yes, just 1 second. Professor Surya Prakash is the nodal officer for coordinating with central ministries, departments for disaster risk management, related planning, research and capacity building for Ministry of Mines, Ministry of Coal, Ministry of Petroleum and Natural Gas, as well as Ministry of Communication, Ministry of Shipping, and Department of Northeastern States, Ministry of Parliamentary Affairs, Ministry of New and Renewable Energy, Ministry of Labor and Employment, DGMS, and National Postal Academy. He is a faculty in charge 6 specialized centers on early warning and communication, hill area development, coastal DRR and R, CRBN, industrial DRR, and cyber DRR. He is a team leader of World Center of Excellence in Landslides in Disaster Risk Reduction from 2011 to 2014 and also 2020 to 2023. He is a supervisor and in charge of Flood Monitoring Cell and Emergency Operations Center. So this is a brief about him. Now I'll hand over the stage to Professor Surya Prakash for his kind keynote address, please. Professor Surya Prakash, sir, please.
Thank you, Dr. Haldar, for providing me this opportunity to speak in the inaugural program of this specific webinar focusing on chemical disasters, which is very important area of concern for all of us, because as the developments are taking place and industries are rising in number and also their activities are increasing with the ending of the COVID-19 restrictions or easing down of the COVID-19 restrictions in many of the areas, some of the likely disasters that may happen because of our ignorance or maybe because of our fallacies in the industrial area. These disasters in the past, they have reminded us a lot. One of the world's biggest disaster happened in our country. That was the Opal gas tragedy, which happened in the midnight of 2nd and 3rd of December 1984, when the methyl isocyanide got released and it leaked from the industry, and about 45 tons of that gas spread over the area and affected a large population in that area. People being unaware were trapped or became victim, and the ill effects of this tragedy were felt for several years, even after the incident was over. So therefore, it reminds us that we need to take care of such kind of events which may happen in the urban area or the industrial areas or the peri-urban areas where these industries are located. There have been several other instances which have happened in this industry. Particularly, I can remind that the recent disaster which happened in Visakhapatnam in 2020 and 2021, when the sterling gas got released after the industry was reopened. And many of the people living in that area, they became casualty because of the toxic impacts of that particular gas. So there have been several such instances. I remember the major incident which took place in May 2020 in the Bagyan wildfire, where this fire continued for almost about 4 months and resulting into not only a heavy economic loss due to the loss of the gas and oil in that well, as well as lot of other impacts which took place in that area due to that fire. So there have been several such instances where we could find that either the exploration, the process, production, storage, transportation, or any other related such activities with the chemical industries, they have led to disasters. What we can do is we can reduce the incidences or their impacts by being proactive in terms of our risk assessment, risk avoidance, prevention, mitigation, and preparedness against those risks. Now, these risks can be due to either human errors, or maybe because of technical or technological failures, or maybe because of management errors. All these must be well identified and assessed. Although the Environmental Protection Act provides the provisions for the environmental impact assessment, and also it gives the ideas about the occupational safety, health and environment to be properly assessed, particularly in the vulnerable or sensitive industries, which can cause huge loss of lives or economic and environmental damages. As my colleague Dr. Haldar said, pollution is one of the major causes of the climate change, and also the adverse quality of the air, which is resulting into a lot of health hazards. And the chemicals which are being released through fumes or exhalations from the industries, they can be controlled by way of certain preventive measures to avoid or to reduce the pollution levels and contain the quality of the air and land and water together. Because some of the pollutants which are being released from these industries, they are also being released either in the solid waste form in the land areas, or in the liquid or the fluid forms in the river systems or the drainage systems that are also getting affected because of the chemical leakages. Now, that is one part of the story. The other part of the perspective is that these industries themselves are also quite vulnerable to different type of hazards that happen in the nature, be it cyclones, be it floods, be it lightning, or any other such disasters or earthquakes which can affect these industries. So we have to actually see the risk from both the perspectives. One, what are the likely risks these chemical industries can result or can generate? The second part of it is, what are those natural risks to which these chemical industries can get exposed? So we need to prevent the impacts and the incidences of both these risks, and also enhance the resilience of these industry and other stakeholders in these areas. Enhancing resilience means we need to prepare the plans for risk reduction and resilience in advance based on the probable occurrences of the likely hazards or the emerging hazards from these industries, and also hazards that are likely to threaten these industries. So we need to prepare their plans in advance and prepare for the efficient response, not only to avoid and prevent, but also in cases where there are remnant risks and which cannot be either avoided, prevented, or reduced. In those cases, we need to prepare for efficient response, rehabilitation, and recovery mechanisms. So these are very, very important. Besides this, I would also like to mention here that we have a lot of legal provisions which have been in existence for long periods of time, may also require some revisions or updation in their terms of implications, which includes the Explosives Act 1884, which was devised during the British times, Factories Act in 1948, Environment Protection Act 1986 and 1988, Public Liability Insurance Act 1991, Petroleum Act 1934, Insecticides Act 1968. And also for the transportation, we had Motor Vehicles Act 1988. So there are a number of such acts which we are utilizing, which are relevant to the chemical industries and also need to be enforced appropriately. We may also require certain revisions and updations in terms of our standards and codes of practices, because many of the new technologies which have come up have not been in existence earlier, and the induction or implementation of those technologies, techniques or processes may cause different type of impacts or incidences which may not have happened in the past. The second part which I would like to invite attention is the changing climatic condition. Lot has been talked about in the international panel on climate, intergovernmental panel on climate change. And we need to also consider the impacts of the rising average annual global temperatures or local temperatures, the changes in the precipitation intensities and distributions and occurrences of rainfall. And these may again cause some kind of disaster situations in the chemical industries. So there are several cases which we need to take care and also manage those situations. There are many industries which are, you can say, in terms of major accident hazard units, almost about 1861 such major accident hazard units have been identified with over about 300 districts and 25 states and 3 UTs. With all the zones of our country, we have also some of the industries which are also forming part of unorganized sector, and these are not well taken care. So not only the organized chemical industries in terms of major accident hazard units, but also the unorganized sectors dealing with the various type of hazardous materials and explosives, they also need to be looked into and examined properly, for that may pose serious and complex disaster situations which may be unforeseen and uncertain in nature. So therefore, we need to actually prepare a comprehensive disaster risk management plan considering all types of potential chemical industries, their both on-site and off-site plans, onshore and offshore plans at all levels, and also in every sector. So these are some of the suggestions that I would like to make in the beginning. Our National Disaster Management Authority had also released guidelines for management of chemical disasters, which also need to be considered while making such plans. We have also a national plan on disaster management, which was revised in 2019, and a national policy on disaster management, which was released on 22nd October 2009. As per Disaster Management Act, every ministry, department, and organization from the center, state, and the local governments, as well as the corporate sector and the private sectors or the public sectors, are also expected to their disaster management plan, prepare their disaster management plan, and linked with the district disaster management authorities disaster management plans. There are a lot of resources which may be required, and all those resources may be pulled together So all these industries in the industrial areas must collaborate with each other, besides the collaborations and linkages with the disaster management authorities at the appropriate levels. So collaboration is the key, and using the resources together as part of the information which is also can be made available through the India Disaster Resources Network. So a lot of efforts are required by the industries, disaster management departments, and other relevant stakeholders. So I wish all the best, and I hope the distinguished experts for the 2 days program, because they are quite experienced, will enrich you with their knowledge, information, ideas, experiences, and innovations that they have. And they will also share with you the possible means to reduce these risks and enhance the resilience. With these words, I wish all the best to our distinguished experts for today's deliberations, and also urge all the delegates and participants to do ask questions to the experts to know what they need to know, or what they are anxious, or what is their inquisitiveness to know about chemical disasters and their management. So I wish all the best, and wish you a safe, healthy, and good quality life on an equitable, justifiable, and right-based manner with good fraternity amongst all of us. Thank you very much, and wish you all the best. Back to you, Hazardous.
Okay, sir. Thank you. Thank you very much. That he has given a very important message. That is, the disaster management plan is vital, and it can give a lot of relief for the disaster if we adopt it properly. So he has given a very vital message to the participant and to this forum. And now we'll proceed further about the today's program. There is first lecture will be given by our Dr. Malay Kumar Pradhan sir. He's a Deputy General Manager in OSDMA, and his topic will be on challenges on management of chemical as well as industrial disaster. Now I will say a brief about him. Dr. Malay Kumar Pradhan, presently he is serving the General Manager F&B in Odisha State Disaster Management Authority. He did his Masters in Heat Power Engineering from College of Engineering, Burla, and he has done PhD on Safety, Health, and Environment from Sambalpur University. He has undertaken various industrial projects on socioeconomic profile, carbon dioxide emission from thermal power station, combustion of gas, furnace, gas blended with coal, and monitoring of industrial equipments in various parts of Odisha. He has number of publications on industrial safety, disaster management, mechanical engineering in international journal, and delivered a lot of various radio and TV talks for the same. And he is also PhD co-supervisor in NIT Meghalaya, SOA University, and KIIT University Bhubaneswar. So this is a very brief and gist biodata of Dr. Malay Kumar Pradhan. Now with this, I hand over the stage to him, and I request to share his knowledge to our participant and panelist.
Thank you, Hazardous sir. So please allow me to share my presentation.
Yes, sir.
So, respected Professor Surya Prakash, the head GMR NIDM, Doctor of NIDM, the other officials of NIDM like Mr. Ajit and Mr. Harihar Kumar, and my colleague and my close friend Sri KJ Patel, the Senior Executive Director of IPCO Paradip, a very positive attitude person. So welcome you all to today's program. So I will now speak on this subject So, sir, my presentation is visible, sir?
Yes, sir, it is visible.
Yes, sir. Thank you.
You can zoom it, sir.
Zoom कर देना वो. This one. Sir, it is visible, sir. Allah, sir.
Yes, sir. Yes, sir. It is
Hello.
visible and
Yes, sir,
audible.
visible. Sir, slides are moving, na? Slides are moving.
Yes, yes, sir. It is
Okay.
moving nicely.
Thank you, thank you, thank you. So let me start with, if you just look into the chemical accidents worldwide, on 4th of August 2020, there was a massive explosion of around 2,730 tons of ammonium nitrate stockpiled in Beirut port, killed at least 181 with 6,000 injured, and 10 to 15 million US dollars property was damaged. The impact of the blast intensified due to densely populated neighborhood. I underline the word densely populated neighborhood has caused more damage to the people. Now coming to two other statistics, in 1984, there was an explosion in San Luis, Mexico, when LPG storage and distribution facility took lives of 500 people and injured 7,000. But in 1966, in LPG similar disaster which took place in France, the life lost was only 17 and injured was 80. Now, if we simply understand that why the impact in France was less and why the impact of the disaster in Mexico is more, it is understood that because the distance of the nearest inhabitants to the hazardous installation was in the range of 1,000 meters in case of France. Whereas in case of Mexico, the distance was only 100 meters. So the only one thing that comes into our mind is a proper land use planning is definitely required. Now coming to the chemical accidents in India, there are many. In 27/9/2021, house range of chemicals at Badlapur in Maharashtra, Thane district. Oil and gas, people have told about that. So in Visakhapatnam, the death toll was 11. Like this, there are a series of accidents. What it indicates is, in spite of the best of the practices, in spite of the statutory provisions of law, in spite of the best of the provisions taken by the management of the hazardous industries, and inside having a good statutory system of implementation, still accidents do occur, and every year the list is increasing. Now, let me have a basic difference, correlation between the two major incidences which has taken place during last 35 years. One, a Bhopal gas tragedy, which took place during 1984. Another, I will speak about the Vijaya gas leak, which took place in May 2020. So after 35 years. Now let us see what is the main cause of Bhopal gas disaster. I hope everybody is quite aware of this, but in short, insufficient maintenance. Protective systems to prevent discharge was out of service. The refrigeration system to cool the reactor was down. Scrubbing system to absorb the released vapor was not immediately available. Flare system to burn vapors getting past the scrubber was out of service and unattended for a long time. And what are the lessons learned? That we must eliminate or reduce inventory of hazardous material. Hazardous material, the inventory should be kept as less as possible, but it should be sufficient so that there will be continuous manufacturing. But we should not stock much, because the more the quantity, more the hazard. Keep all safety related equipment in order. We must see at a regular interval, through plant safety audit, through regular inspections, that all the safety gadgets which are inbuilt or which are mounted or fitted to the equipment must be in order. Keep residential areas away from the plant. Many times what is happening, even if in all chemical accidents, in chemical industries, the people with their family, they stay very close to the industry. So in case of a major leakage of a gas, there is likely chances that even the family will be also put to problem. So looking into that dispersion modeling, we have to understand what is the maximum distance the gas can travel and which is the most wind direction in that locality. So the residential area should be away or some way away from the wind direction and beyond the dispersion modeling that what is the maximum distance the gas can travel. Effective emergency planning is definitely very much important. The risk of exposure for host population from a hazardous work environment. Now, what we must know, even the nearby, now in case of an industry, when they are handling some chemicals, definitely the industry people, they know about the thing. It is equally important that the district administration and the statutory authority must also know that what is the manufacturing process going on, what are the chemicals being used, and in case of a problem, what will be the maximum damage it can cause, so that what will be the preventive measures or what will be the immediate reactive measures at the time of incident. Unless otherwise all the things are known to all the statutory authority like police, the fire, district administration, inspector of factories, it becomes difficult to handle it at the time of need. And the next one is the locality who are staying close to the vicinity of the plant. Now, because if it goes beyond the boundary, it starts flowing just in case of methyl isocyanate in Bhopal. So the people will also be affected. So what is the minimum requirement they have to do? They must know. So which compounds we might be exposed to from chemical plants? That's the people must know. What way and degree these compounds are harmful to us in short term and long term, and involvement of NGOs and trade unions to fight for the best for human beings. These are the lessons learned from the Opal gas tragedy. Now let us quickly come back to Vijaya gas leak disaster. What happened? Now again it is an uncontrolled sterile vapor released. Vapor cloud spread over a radius of 3 kilometers, affecting the nearby areas and 5 villages. The death toll was 25 people critical. More than 1,000 people became sick after being exposed to the gas. Around 585 citizens got hospitalized. Issues faced are breathing difficulties and sensations of burning eyes. Now, what are the lessons learned? Insufficient maintenance. Just I am going back. There also the lessons learned to us inadequate or insufficient maintenance. In this case also, this is insufficient maintenance. Change in design of cooling system, improper storage like inside lining was not there, operation errors like temperature taken from bottom, valve malfunction, only one temperature sensor was there, high temperature alarm was not available, unattended for a long time. So even after 35 years, with lot of statutes available, with lot of information available, with disaster management plan in hand, but still the similar things are happening. So that's why it requires a holistic approach in respect of the industry people, in respect of the statutory authorities, and in respect of the general public, that we must know what to do. And we must also know whether the other people who is in hand of the affair is whether performing his job correctly or not. Unless otherwise awareness in all these things are not happening and regular monitoring, regular reviewing of the system is not in place, it becomes difficult and similar. Now, coming to the basic definitions of a chemical disaster is the unintentional release of one or more hazardous substances which could harm human health and the environment. So this is an unintentional release. Nobody wants it to be released, but it gets released of its own. And in the process, it can cause damage to the human health and the environment. Now coming to the chemical hazards. Chemical hazards are systems where chemical accidents could occur under certain circumstances. So it is the responsibility of the authority or of the management of any chemical installations to identify the chemical hazards, means where in the system there is chance of chemical accidents. And after identification of the chemical hazards only, the precautionary measures will start flowing. Now, chemical accident. Chemical accident means an accident involving a fortuitous or sudden or unintended occurrence while handling any hazardous chemical, resulting in continuous, intermittent, or repeated exposure to death, injury to any person, or damage to any property. So, this is the basic definition of chemical accidents. Now, let us see how the chemical accident originate. Now, these chemical accidents may originate in manufacturing or formulation facility. In a facility where these chemicals are being manufactured or the chemicals are being formulated. Formulated means one or more chemical mixed in a certain proportion and converted into a different proportion. Or in a manufacturing process where hazardous chemicals are being used as a raw material. So this is called your manufacturing or formulation facility. Then during the process of operation at any stage of the product cycle, any stage of the product cycle means even storing of the hazardous chemical, even pumping of the hazardous chemical from the storage point to the system through pipelines, and use of the chemicals at the processes. So at any point of the product cycle, there is chance of leakage because things are moving at a speed, at a pressure more than the atmospheric pressure. And in case it leakages, then definitely it has got a hazardous activity and it will cause injury or etc. Another is material handling. Even material handling, that material handling may be inside the plant or may be outside. So that material handling from one point to another point, that also can lead to problem. Then transportation of hazardous chemicals, that is HAZChem, hazardous chemicals. Now this transportation of hazardous chemical is very much vital. And these transportation can be on road, can be on rail, can be on air, can be on water, or can be on underground pipelines. As you see in the national highway, you might be seeing a lot of LPG tankers, lot of petrol, diesel, butane, propane tankers are moving. Now, at any point of time, suppose there is an incident and the LPG starts leaking, where there is a high potential, it can cause, it can catches fire, and if not attended to quickly, it can also explode. Similarly on rail, similarly on water, many ships are coming and lot of hazardous chemicals are being transported. And latest, that is one, is underground pipeline. So underground pipeline transportation, these are again having three types, maybe one a crude oil, maybe a product system, and maybe a gas line. So all these lines, when it passes through underground, now in a city like city gas distribution networks, in any city you will find that thousands of kilometers of pipeline are being planted on the underground, and it is being supplied to the domestic, to the commercial, even to the industries. So in this case, definitely there is chance of an explosion or fire. And the vulnerability is sometimes compounded due to location of a major accident hazard industry closer to densely populated areas. I have shown in the other slides that in France and in Mexico, the vulnerability in Mexico was increased because the hazardous location was very close to population. So that is a very vital thing. Now, whenever a major accident hazard unit is available, we must see, depending on the dispersion modeling, what is the vulnerability zone of that MH unit. And best of the care should be taken that in that vulnerability area, close or densely populated clusters will not come up. Now, the causative factors of chemical accidents, it can be in the shape of a fire, it can be in the shape of an explosion, it can be a toxic release like your ammonia or chlorine, like poisoning, like CO poisoning in blast furnaces or in sponge iron plants, etc. Then combination of the above, even in some time, a toxic release can lead to a fire, or a fire can lead to an explosion, and even the cascading effect are also there. In one unit, in one industry, in different zones, so the fire can spread, or from fire from one industry can travel fire to the other industries also. Now, there are certain technical errors. The technical errors are the design fatigue, corrosion, the human errors like procedure deviation. Many people who are in the helm of the affair, who are required to do the job, they sometimes make a procedural deviation, then neglect of safety instructions, then lack of information and organizational errors, that is poor emergency planning, also sometimes leads to problem. Now, the compounding effects of the chemical accidents. Now, these chemical accidents, the intensity will become more depending on the wind speed and direction. Now, depending on the wind direction, definitely your vulnerability zone will increase. Instead of an entire circle, only a sector will be affected depending on the wind direction and speed. Then rate of precipitation, toxicity or the quantity of the chemical that is being released, that is also very important. And population in the reach of release. How many people are available in that reach? That is the densely population that will create more problem. And the probability of formation of a lethal mixture and other industrial activity being performed in closer vicinity. So a cascading effect can also take place. Now coming to the disaster risk reduction, DRR. The disaster risk reduction is defined as the concept and practice of reducing disaster risks through systematic efforts to analyze and manage the causal factors of disaster through reduced exposure to hazards. So once we identify the hazards, we will try to see that the exposure to the hazard will be reduced. Less and less people will be exposed to the hazards. We will give some barriers or we will isolate the system from the main source so that less people will be exposed to this. This is one of the system. Then lessen vulnerability of people and property. We have to see that the vulnerability to the people will be lessened. So definitely, depending on the wind direction, depending on the dispersion modeling, in that particular vulnerability zone, suppose we redistribute the things, rearrange, definitely it will be better. Wise management of land and environment. Wide management of land, you see there is a core and buffer zone concept under OISD rules. Now suppose one industry is there, as per Oil Industry Safety Directorate system, rules, regulations, they say all their hazardous activities that will be located or placed in the core zone. And there will be another concentric circle just beyond the core zone, that is called buffer zone, where the plantations will be there. You can have your office, you can have your stand, you can have your garage, etc., or some storage, etc. systems are there. Now, if another industry is there, is a neighbor industry, they are also having a core zone and buffer zone. So now between two core zones, you are getting two buffer zones. So by that also the vulnerability will be reduced. Otherwise, in earlier practice, now suppose you are having any hazardous system, as a matter of practice, what they do, they were keeping at one corner of the building or one corner of the plot, all hazardous substances are there. Now, depending on the wind's velocity, now suppose in case of a leakage, and if the wind direction is such, now the chemicals or the hazardous substances, it will start moving to the neighbor plant, and the people in the neighbor plant will be affected, whereas there is no injury, no problem in the main plant. So a wise management of land and environment, the rules are also coming up. Then improved preparedness for adverse effects. Then disaster risk reduction and resilience. Inventions aim to reduce and mitigate the risk of displacement and increase the resilience of the communities to cope with disasters. You see, earlier, whenever the cyclone was there, now what we want to do, that we want to rescue people. People where now there are shelter houses or flood center or cyclone centers are there. Now they are coming. And whenever the buildings which are not resilient to the cyclone or because that register, so what will happen? Now this will break and you will get some compensation. So every year, now suppose more than one cyclone is coming, then every time, every year you are going on giving compensation to the people for their broken houses. Instead of that, if we can construct pakka buildings or some structures to the people and we give them, So what will happen? Now the chance of collapse or destruction of the buildings are avoided. So that become a resilient structure. So in suppose in coastal area, even if the industries are there, now we can understand because of the cyclone, the wind speed can go up to 200 km/h. So whatever the building structure, chimneys or high-rise structure, etc., are available in the factories, we must see that the minimum resistance of the structures are more than the maximum permissible wind velocity at the particular point in last 10 years or 20 years. So then we can say that the structures or buildings are resilient. The next is a good warning system to save lives, prevent injuries, and mitigate losses. Now, you see, warning system, particularly in cyclones, we can know the path, maybe minimum 3, 4, 5, 1 week before. We can know that this is the path that is going to move, and this is the maximum speed it can happen. But coming to a chemical accident, now suppose ammonia is being stored in one vessel or in one storage devices. Now, when it will leak, how it will give warning, it become very difficult. So the intensity of the chemical accidents are definitely more, but the frequency is less. And we hardly get any warning system. So the only warning system that we must see that whatever the parameters, even it may be the pressure, it may be the temperature, it may be the flow velocity, or it may be the thickness of this system, corrosion, etc. We must have good sensitization systems so that it can understand the pressure is becoming more, then warning will come. Because in a chemical accident, we simply cannot allow it to come. We must see that such accidents will not happen. So effective evacuation from hazardous areas, regular follow-up, communication, these are all the disaster risk reduction methodologies that is required. All relevant authorities at the local, regional, and national level should be fully prepared and have the proper equipment and training in place to deal with any accident scenario. What we want to say, suppose a factory, they are handling chlorine. Now, suppose there is a leakage in chlorine, what exactly they will do? The management of the industry, they know, because they are having an on-site emergency plan, they conduct mock drills, so they know. But what exactly the district administration will do, what exactly the police will do, what exactly the fire people will do, what exactly the nearby locality will do, they require a regular training and they must have the equipment. Now, suppose chlorine, the person will be rescued. They simply cannot go of their own. They have to have their aprons, which are very with oxygen mask, etc., available, so that they will not be trapped with that hazardous chemical. Otherwise, it will become very difficult. So we must understand that what is the chemical that is used, what are the properties of the chemical, and what are the precautionary measures to be taken. And in case of an emergency, what are the steps also required to be taken. So avoid housing near the industries, producing or processing the hazardous chemical if possible. Participate in all the capacity building programs organized by the government or voluntary organization or industrial units, and take part in preparing disaster management plans for the community and identify safe shelter along with safe, easy access routes. So the other things are, one is NATEC. NATEC is a technical accidents triggered by natural events. You see, particularly in India, is having a vast coastline. Now, across the coastlines, now there are also chemical industries, there are also MS industries, all petrochemical industries. So all these are located in the coastal belt. Now, in a natural event, just like suppose cyclone or flood, so it can also lead to a technological accident. There are many incidents all over the world. So the industries who are located in the coastal areas, or maybe in an area where there is high chance of flood, or maybe in an area where there is a high chance of earthquake, so they must have adequate knowledge on the thing, and all their structures should be resilient to the hazards. If it is a earthquake prone area, so the building must having the earthquake resistance. If it is a cyclone prone area, so the building must have the adequate strength against the wind speed to resist the wind speed. So all the things are very much important, that That is one thing. Then ownership change in hazardous facilities. This is very much vital. What happens in many industries, in chemical industries or MH units, now the ownership gets changed. And in the process of ownership gets changed, so the original design, the original system, procedure, the all SOPs, etc., whatever was there, now all the things must pass through the new management. So that particularly should happen, may not happen also. And even the attitude of the management will vary. Now, because if the top one, the ownership changes, yes, factory X was managed by a owner, suppose A. Now A was having very much, suppose, safety concerns, they were doing everything to right owner. Now when it change over to the owner Y, so what will happen? They are having their set of mind. So the safety system may vary. It may be better. So it is definitely good for the system and organization. But suppose this new management is not so much safety conscious. Their only system is to production because they have spent money, etc. Definitely it will create more problem. So that also we have to look into at the time of ownership change. All these systems, particularly safety in chemical industries, must find place in their MOU or in their agreement. Then aging of installations. Each installation has got a particular time period, just like boilers. Once it attains 25 years under regulation 391 of IBR. So there is a pressure reduction for fire tube boilers. And in case of water tube boilers, we have to go for remnant life assessment of the equipment. Similarly, for any other chemical plant, so involving the hazardous chemicals, so aging factor should be considered. There should be periodical after a certain age of time, depending on the statistics of failure statistics. We must go for again the remnant life assessment of the installations, and we have to ascertain whether it is okay or not. If not, whether we can go for modification. If not, we should replace it. Then the inspection approaches must also vary, particularly under CICG, Centralized Inspection Core Group System. Even these inspection approaches are there, particularly in Odisha. Like all MH factories are required to be inspected at least twice in a year. Whereas for hazardous factories, it is required to be inspected once in a year. And for other, which are non-hazardous, they are to be inspected once in 3 years. So it indicates definitely due care is given to the risk, and accordingly, all care is also taken for the MH unit to be inspected twice in a year. Now coming to the challenges. The challenges is, one is lack of visibility. Now the limited public databases on chemical accidents, statistics on deaths are recorded, but not property or environment. You see, lack of visibility means a chemical accident is very important. So how it gets the attention of people? If it occurs in the magnitude like Opal tragedy, it occurs as a magnitude just like Sterling gas in Vijaya. But every day or every month, small or minor incidences are happening, but which are neither causing any injury to the people or damage to the environment. These are not addressed, no database is available. If database is not available, definitely we are unable to also take precautionary measures on this. And in many cases, the statistics on deaths are recorded, but not on property or environment. So what is the environmental damage it caused? These things are not taken into consideration. And now the latest principle is the net zero. So in the globally, there is a system or program that by 2050, they will attain net zero. In India also, the Prime Minister has already given an assurance that by 2070, India will be net zero compliance, means zero discharge, zero emission. Now, unless otherwise the records are available, now you cannot say that in which industry you will focus your attention, because there are a lot of industries available all over India. Now, which industry to be addressed fast? So all these things depends on the data. Then failure to manage risk across boundaries, failure to communicate information to those who need it, both internally to organizations and externally to other industrial sectors, professional disciplines, engineers having little training in human and organizational factors handle the issue, failure to see beyond one's own boundaries, foster a piecemeal approach. what I want to say, suppose a chemical industry is available. Now the worksman controller is definitely the person who is the technical head. Now these persons is now the worksman controller in case of a chemical accidents. Now the only point is the engineers who are doing their main job in production or operation, they definitely lack in their managerial ability to discuss with the district administration, to discuss with other things, all the things. So the capability upgradations, that is definitely required, because particularly in these chemical or MH units. So the engineers must also have the managerial ability, and particularly suppose a person with an MBA must be given the head in some places so that their performance will be better. I never say that an engineer cannot manage it well, but what is happening, there is a lot of things are required, because in case of a chemical accident which is gone beyond the boundary, then lot of information you have to inform to the police, the coordination with police, the coordination with fire, district administration, other experts, the MARG, the mutual aid response group systems. So all the things are required. So you have to make even the NGOs, even the people, all the things, mass media, communication, all the things which are required, a sort of managerial ability. What I want to say, the top person in a chemical or MH units must have some input on the managerial ability. Definitely that will be helpful, because otherwise it will become a challenge. Now, failure to learn lessons from the past. Failure to learn lessons from the past or incapacity, like suppose in Bhopal tragedy, again the malfunctioning, again the safety system was not there. It was not attended to quite long time. In Stirling gas after 35 years, also the same problems happened. But why? Now, because any accident took place, people become serious, and that seriousness continues for maybe 2 years, 3 years, 5 years. But after that, again people become relaxed. So chemical accidents, its frequency is less, but its intensity is very high. That should not be, we should not forget it. Then social drivers, including economic trends, employees tolerate bad conditions because they need jobs. Delay in maintenance and repairs on aging sites to keep costs down. In some organizations, chemical plants, it is generally the people who overcome the hazards. Even if they point it out to the management, they don't take any action. They delay the maintenance, they delay the repair only for the cost control issues. And the employees, they tolerate it, because if they will not tolerate, they may lose their job. So that is the economic trends and social drivers. So these are available. In that particular case, now there is no law, particularly although the inspector factories are available or the statutory authorities are there. Now for a clear and transparency systems, we must understand for a chemical accident like this. So all this system like safety audit. Now safety audit is a system. It is also defined under the Act. It will be done once in every year and once in 2 years by external agencies, and whether it is implemented or not. So all the things are required to be intensified. Then increasing complexity, the tight production schedules and budget cuts convert problems related to safety issues to maintenance issues. Now what happens? Now in industries, we are having a very tight production schedule. So orders have come out. Now if you can go for a, suppose some maintenance will go, or some process change you will try to make. Now you don't have a budget is one part. Second part is your production schedule is so tight that you cannot stop your production. So and these chemical accidents are sandwiched between your tight production schedule and the budgetary cuts. And this also creates problem. Then automation and information technology dependencies. Many times we simply depend on the technological whatever is available, and many times this can also now so pressure gauge can give a error, the temperature gauge can give a wrong information. So there should be a cross-check methodology also available Otherwise, too much dependency on technology can also lead to problem. Any malfunctioning, etc. These are required to be reported at the earliest. And the other challenges that I have already told, the land use policy, the no statute except OISD. It gives a clear-cut guideline on the land use policy, but under the statutory provision of law, particularly in Factories Act, there is no such policy where it indicates that where the location of a hazardous chemicals be and what will be the minimum distance of the locality, etc. from that area. So that land use policy like core zone, buffer zone, or if suppose in a dispersion modeling, suppose a fertilizer plant is there, Patel Saab will definitely speak on this. Suppose in case of a catastrophic failure, now it can travel up to 5 kilometers. And within that 5 kilometer area, what is the use of that land? How it is being used? So how safe? So let us consider the worst case. There is no rule for that. Definitely it is a challenge. Then rules pertaining to transport emergencies. During transportation of hazardous chemical on road, rail, etc. Suppose there is a toppling of a tanker, etc. It can lead to problem. So there should be the responsibility of the chemical unit. Suppose chlorine, a factory is manufacturing chlorine and a transporter, he takes out chlorine from that unit and he is traveling to another unit or somewhere to the user site, which is 400 kilometers away from the plant. Now, it is the responsibility of the chemical plant to see that the transporter who is taking the chemical from his factory must reach at the site or the user site safely. And at any point of time, in case of any problem, they must attend to that accident at the earliest, and there should be relevant rules and regulations for that, which are not available. Even the transporters, they are also having the responsibility, because once you are transporting a chemicals, you know that there are inherent hazards associated with the system. So whoever the drivers, etc. are available, they must take all precautionary measures while passing through a busy locality, while stopping their, moving their vehicles or overtaking or any, whatever the thing, the transporter must be, the drivers, the authorities, they should be responsible for this. Web-based accident information system. Now, this is not full-fledged in practice. Whenever there is a, suppose on the road, there is some accident. Now, if a web-based accident information system is available, then definitely the indication will go to all stakeholders. Like police will get the information, fire will get the information, district administration will get the information, RTO will get the information. So all will be mobilized very fast so that all information is available, so people can know. So it will become very easy to handle the emergency situation at the earliest and on priority. Mobile hospital is a new concept. Suppose a person is affected by CO poisoning, suppose in one industry, a worker who was found he is unconscious. Now what will happen? Now the system has to be stopped and a team with all precautionary measures will go and rescue the persons. And once rescued with the help of ambulance, they are rushed to the hospital. And hospital, the doctor, etc., they are not aware. So it will take some time. So getting infected by the gas and getting the treatment, the net time is increased. Now, if we are having a web-based accident information system, immediately at the time of release, now the CDMO gets an indication that yes, in such and such factory, there is a chemical gas poisoning. So he will send his mobile hospital, means a van with doctor and with equipment and with medicine. It will, instead of the patient rush to the hospital, the mobile hospital, means the ambulance, mobile ambulance, it will rush to the accident site, so that by the time the victim is rescued from the confined space, now immediately the doctor is available to give him treatment. So by that, the time of treatment is reduced, and by that, the life of people, the chances saving life is more. Similarly, the industrial pocket-wise hazard analysis. In a particular area, more and more industries are available. Each industry is making their own hazard assessment. But it becomes the responsibility of the district administration also, or even the industrial house taken together, to have a overall industrial pocket-wise hazard analysis. So what can go wrong if something, a chemical industry is there? If there is a fire in that industry, so what is the rate of propagation? Which are the other industry they are going to be affected? What is their potential? Whether they are equipped with that or not? What is the system of the local fire station? Whether they are having that system or not? Whether the water facility is available or not, whether the foam materials are available or not, whether the particular trained people are available or not. So all the things we can also have an industrial pocket-wise hazard analysis that will definitely help. Then vulnerability and risk assessment of transportation of hazchem stretches. In a particular stretches, now suppose a hazardous chemical truck, a tanker has entered. Now how we will know? So the quickest you get, suppose we are having a web-based information system or we are having a GIS connected system. So entering into any district, now the district information will get at least the emergency officer will get some indication in the mobile that such and such tanker with this chemical has entered into this district. Now the local police station, they will also get an information. The OIC of the police station will get a message in his mobile that such and such has entered into his police station jurisdiction. Now the fire station, and the local fire station, the in charge will get an indication that yes, such and such has happened. Definitely this will help so that they will be aware that things are happening. GIS-based communication system for transport sectors. So these are the certain challenges. Now coming to the Prime Minister's 10-point agenda for DRR, in the Asian Ministerial Conference on Disaster Risk Reduction 2016 held in New Delhi during November 2016, the number 5th point is leverage technology to enhance the efficiency of disaster risk management efforts. So this is definitely today's this webinar also highlights on this, that how the technology can be utilized to enhance the efficiency of disaster risk management efforts. On that, I will speak a little more. Now, the developments in access to data through Earth observation technology, street level imagery, connected devices, and volunteered geographical informations. These are the new technology. Unless otherwise we are having a first and foremost information on this, it becomes very difficult. Particularly, suppose in the state of Odisha, now somebody will ask that how much chlorine or how much ammonia is being handled in the state of Odisha. Immediately, I must be in a position to answer. If so, I must have data, district-wise, industry-wise, what is the maximum storage capacity, what is the inventory capacity, what is the real-time figure available now in factory X, if they are storing ammonia, how much quantity of ammonia is available today at this point of time. If these informations are readily available with us, it becomes easy for the district administration or for the mutual aid team, or this is important. Now, Stalin gas leaked. At the time, we are only interested that yes, it leaked at this time, stopped at this time. What is the flow velocity? How much quantity of Stalin gas was available? And what is the quantity it leaked? Now, if all the data are available to us, then immediately with this modeling methods, we can know the dispersion from the dispersion modeling, we can know the traveling distance, and we can give a alert and a warning system to the people nearby that this much quantity of gas has leaked with this velocity. This is the sectoral area it is going to be affected, and immediately now evacuation team will try to rescue these people, and other people will not be allowed to go to that area. So it becomes a little very specific and pointed approach for disaster management. Improvement in the capacity to process and analyze this data through cloud computing platforms and big data analytical techniques such as artificial intelligence. All the things are required. If artificial intelligence is nothing but if data are available, it can give us a point out that you must do this. Depending on the failure rates, it will give you the indication you have to do like this. Then increase capacity to transmit risk and risk management information as a result of the proliferation of internet and mobile access and continued improvement of broadband and data speeds. Indian Disaster Response Network (IDRN) is a nationwide electronic volunteer of specified specialists and essentials resources for disaster response. The primary focus is to enable the decision makers to get details of readily available and updated information about the equipment and human resources required to combat any emergency situation. Just what we are doing, just like in mutual aid response system. In a particular locality, suppose one industry is there, he is making a mutual aid agreement with other nearby industries. And in that particular, that format is developed where it gives us an indication that the factory A is having the hazards this, or flammable material this, toxic material this, and the chances of disaster is this. Factory B is this. A is having these resources, manpower, this equipment available. B is having this manpower, these resources available. And in case of emergency, A can provide these resources to B, and B can provide these resources to A. All this, there will be an agreement, so that in case of emergency, you can call. Now, if this is further and it is made broad, so now from the locality to the district, from district to the state, from state to the entire nation, we can have a network and we can communicate with people, and at the time of need, we can utilize the man material service. Now, these technologies find application in disaster management. One is a drone technology. Drone technology means, suppose you are having a big chimney. This chimney for inspection, regularly you cannot inspect. Once, suppose when a shutdown is taken, then only people are allowed to go to the top and they do it. But if you are having a drone with a robotic control from the base, now that drone can move around 24/7 and it can find out what is the thickness, whether any wall is there, whether any crack is developed or not, whether any corrosion is there or not. So all these systems, drone technology can be done. So other artificial intelligence, Internet of Things is the very latest technology, even for the safety purpose. It can also identify any unsafe behavior caused by a person. Suppose a person has been given a helmet to use, but in the process he has not used it. So the information of things can also identify that. It can give a message to the responsible person, the site in charge, the department head. A message will go that Mr. X is performing the unsafe actions. So that will definitely help. These are the very small things, but if you do take care, definitely the large or the hazards that will not happen in the past. Then robotics, then blockchain. Blockchain technology can help mitigate concerns like lack of trust, transparency, measurability of the relief efforts, and ensuring the resources are used for the intended purpose and enable rapid collection and management of reliable data. So all these are the technological interventions which are already in use in the Western countries, are also in some way or other is being used in India, and this is required to be made compulsory to all MH units at the first go, subsequently to all the hazardous industries, so that it will, just like it will try to take care of a seconds, ours will take care of themselves. Similarly, these measures will take care of the seconds, and definitely the problems will be over. So last, I want to say, failure to prepare is prepared to fail. Thank you very much, sir. Allah sir, thank you very much.
Thank you, sir. Very, very elaborative description you have given for the precautionary measure and other points of view. That certain things you shared rightly, that is the internet. Through the internet, the message should be passed. It means the webcast, that whenever some accident is there, that web-based information should be there, so that mobile team or the mobile hospital, it will be in position to reach the site or on the way, so that public or the person who is injured, it could be saved his life within a short time. And also the internet information, that whenever some hazards are there, that police, they will get the information. Whenever there's some transport, hazardous chemicals they are transporting, they should know and it should be aware. So it means that present technology, it can give some relief and we have to use that. And also you have highlighted rightly that Western countries, they are using the drone technology, artificial intelligence, robotic, blockchains. And India, we should also be aware, we should use to minimize the failure, the disaster, to minimize the disaster and take precautionary measures. So very wonderful lecture you have given, and each pros and cons for the accidents you have highlighted. So I hope the participants have could be benefited very much for the, at least for the industrial and chemical disasters, what are the precautionary measure and how it could be saved. Now, thank you for that very much. Sir, only one question is raised, but that is not also very clear. You can
Yes,
also
sir.
see that is around Mr. Tek Vidyasagar is asked that it is not very clear, but however, I am reading. First question is that, sir, just one second. First question is that two questions he has raised, but the first one is not that much. Sir, please listen. And I will ask you for the, if at all any answer is there, then you can highlight, sir. By default, he has written, by default, plants are designed and located away. Unfortunately, due to bad land use planning, habitation is moving close to industry for various reasons. I could not find exactly what you want to ask, sir. So what I feel that he may be asking, by any means, that due to bad land use planning, the habitations are getting closer to the industry, then what would be the best possible to save the people?
Yes, sir.
At 11:42.
Sir. Yes, sir. He is absolutely correct. You see, the siting criteria given by many state pollution control boards, particularly in Odisha, I am telling you, there was a siting criteria for the stone crushers. That each stone crusher must be at least 500 kilometers away from the national highway and state highway. And between two stone crushers, there will be a minimum distance of 500 meters. And each stone crusher should be at least 500 meters away from the locality. And this is only a one-way service. What the participant has really raised is, now over the period of time, when the stone crusher was sited, at that time there was no locality within 500 meters of the stone crushers. But slowly and slowly, now locality started migrating to the stone crushers. This happened in Raulkela steel plant also. This happened in many of the plants all over India. Now at the time of setting up, they are placed in a very remote areas. There was no locality, nothing, etc. And slowly and slowly, because of business, because of some other supply chain management system, etc., now the population started migrating to the locality and it becomes more. So I have really told that this is definitely a challenge for a chemical disaster management. Unless otherwise there is a government interventions, there are applicable statutes to restrict that once, just like now new concepts are the industrial estate concept, the food park concept, the chemical industry concept. It says, so we have to identify some localities where only hazardous or chemical plants will be available, and there will be a good land use planning of the neighboring areas, so that depending on the dispersion modeling, if some chemical is being handled, how much the maximum distance it can travel, and during that vulnerable area, we should try to give the priority to some things where there will be less population or no population. So these statutes are now not available in our country, and hence it is definitely a challenge for chemical disasters. So that is what because I have already in the first slide also I showed you that in France the death was 100, whereas in Mexico the accident was much more. It is because the plant was in the close locality. So it is definitely a challenge now. The government of India, they are also seriously thinking on the line, and it is definitely a challenge to manage the chemical disasters. I totally agree to this, and there should be applicable rules and regulations for that also. Even there should be awareness for among the people. Instead of only government makes rules that you are not allowed to go, even the people must also know once we go there, then definitely our chances of risk is more. So knowing that, they must go. So that public awareness is very much required. Thank you, sir.
Thank you very much. Very nice answer and appropriate answer you have given. And one more thing that Dr. Praveen Kumar, he asked one small one question, sir. What should be the most effective early warning system? Which tools or techniques or technology is being used for mitigating the present hazard? Is there any is there any early warning system? Is there for
in early? I have already told. These early warning systems are very much pertinent for the natural disasters like cyclone or flood, etc. But coming to the chemical disaster of suppose fire, there is no early warning system. You cannot predict that in this building there will be a fire tomorrow. So that's why I have told the chemical accidents, the intensity is high, but frequency is less, and early warning is not possible. So that's why we have to make early warnings. Means we must see that the procedures, the systems, deviation should be arrested. Now suppose ammonia is being used. Now the storing capacity of the ammonia, all precautionary measures like safety gadgets, safety devices should be in place. That should be audited, etc. Now when it goes to the system, the pressure gauge, the temperature gauge, the airflow, all the things, all the warning system must be available, so that it will give early warning before disasters and there will be no disaster. But in chemical accidents, that early warning system is practically not possible. The reason is you cannot know that when there will be a leak. When ammonia will leak, if the industry people will know, then only they will leak. But why the industry people will try to leak it? So it is definitely, if you bypass the systems, these incidents like in Bhopal tragedy, in Sterling gas, we could understand the lessons learned that it was not attended to quite long time. The safety gadgets were defunct, it was not replaced. Audit was not being done. The cooling system was stopped. So these are the early warnings. If you start bypassing the system, if you try to make shortcuts, if you try to flout to the safety instructions and procedures, so these are the early warnings for disasters. But there is no full-fledged warning system just like cyclones. Thank you, sir.
Thank you very much, sir. From America, Professor Ramesh Singh Sab is there. So he's a professor there, and he's Indian origin, and he was also IIT Kanpur professor. He want to add some comment. So I would request, I unmute him. He has requested to unmute to add some comment. I would request Professor Singh that please be in view of time constraints. So please be completed within the 1 or 2 minute maximum, sir. So I have unmuted you, sir. Could you hear us?
Dr. Aldar, for providing me link. Okay. And I'm very happy that Dr. Pradhan, he covered, he gave a very good talk covering about the chemical disaster and also about the cyclone. I do agree with whatever he said, but I would like to add here for the chemical disaster, like here in United States, every houses has a deployed a small portable sensor for the carbon monoxide, CO2, and other thing. Okay, so why not in India? We should ask residents and the companies, small companies, to install, deploy some portable sensors. Okay. Keep I'm away from the 6 miles from my university, and whenever there is a fire occurs on our campus, we do get the information on our telephone. So whatever you and he said about the internet, of course, it helps very much. And also, we should insist people, worker in the factories, to use a mask. Okay, I remember the 2009 IOP Jaipur fire, you see, and then forest fire trust, not the forest fire, but the fire smoke, depending upon the wind. Whatever he was asking, saying about the dispersion studies, one can see from the satellite and now with the drone, yes, it really helps. But I would like to insist the different, all the companies, people to install portable sensors. Now these sensors are very cheap, so that we get warning and we can alert people. Of course, for example, right now the Ukraine, there is a fight going on, and whenever the bombers come and try to bombard, there is the siren goes on. So similar things we should also deploy. So thank you very much. Okay.
Thank you, sir. Wonderful comment. And whatever you have observed and you have given added in this forum. So thank you, sir, for your good suggestion and good improvement. Now I'll thank you, Pradhan Sahab, for you have
Yes, sir.
given nice time for that, for the benefits of our participants and for NIDM. Thank you, sir.
Thank you, sir.
Now,
Thank you.
Now I will request Dr. Patel to be come to the stage, and before hand over to him, I'll share his about him to the participant. So just 1 second, sir. Okay, I'm making him as a presenter now. Before that, I'll say that Mr. K.J. Patel is a presently Senior Executive Director and Unit Head in IPCO Paradip Unit, Paradip, that is in Odisha. He's a mechanical engineer of 84 batch from Gujarat, and he has a vast experience in maintenance management, project management, operation management, with specialization in inspection and reliability management in various capacities at IPCO in different units and JVs, including IPCO Kalol, OMIFCO Oman, ICS Senegal, and IFCO Paradip. Sri Patel has acquired in-depth understanding of equipments, plant, and processes, excellent managerial skills, and a great business acumen. He has over 37 years of experience in operating, maintaining, managing some world's largest fertilizer manufacturing plant in India and Oman, having international technologies such as ammonia technology of Haldor, Topso, Denmark, and KBR in USA, urea technology of Snan Progrity, Italy, and Stamicarbon, Netherlands, DAP, NPK, and phosphoric acid technology of Jacobs, US, and sulfuric acid technology of Autotech, Lurgi, Germany. Sri Patel has presented numerous technical papers in many international conferences for which he has traveled many countries worldwide. He has actively contributed to the development of young professionals in the fertilizer industry in India and abroad by offering himself as a regular faculty at Fertilizer Association of India's annual maintenance meet and other programs. His core competence lies in the areas of troubleshooting and condition monitoring of rotating equipment, root cause of failure analysis, risk-based inspection planning, NDT, welding procedure specification, and PQR, inspection and troubleshooting of static rotating equipment. He has demonstrated technical expertise, vibrant leadership capabilities, and great business acumen in his role as the unit head IPCO Paradip unit. in March 2019. With his holistic and focused approach, the unit surpassed new summits of productivity. In the past 3 years of his tenure at the leadership position, the unit has broken all the important records like highest daily, monthly, and annually or yearly production of fertilizer and phosphoric acid and the fertilizer dispatch. In his leadership, the unit surpassed the design capacity of the first time in the history. And now the unit is gearing up to achieve more than 120% of capacity utilization. Under the visionary leadership of Mr. KJ Patel, IFCO Paradip unit has won host of national awards for excellent productivity and safety, environment, and energy performance of the unit. Mr. Patel has declared the most inspirational personalities of Odisha for the year 2020 award by interview of Times Magazine. So he's really, after having this biodata, he's really asset to the India, and we are proud to him. Now with this, I would request that whatever experience he's having, that how he makes India proud for us, and so much 120%, and that production he has given at the right moment. Say he's definitely, we are proud for him. Now I request Dr. Patel, so please take the stage and please go ahead for our participants.
Thank you very much, Dr. Haldar, for introducing me to the audience, to the participants in such a big way. Respected Dr. Haldar, respected Professor Surya Prakash, respected dignitaries from NIDM, respected Dr. Malay Pradhan from OSMA, and dear participants. I'm really feeling extremely happy that I've been given the opportunity by Dr. Haldar and NIDM to present before you our the main topic of the day, that's the challenges of disaster management. And my idea is that how to control the disasters before they are born. I'll first request Dr. Haldar to please allow me to share my presentation, please.
Just 1 second, sir.
Yeah. Yeah, I hope my presentation is visible to the participants.
Yes, it is visible and you are audible very much, sir.
Okay, thank you. Thank you very much. So before I start my presentation, I'd like to thank once again NIDM and also the kind of presentation what Dr. Pradhan has made in front of us. In fact, there were many questions as well as there were many points which were asking about the preparedness of the industries. And there I would concentrate more because the presentation about our storage and handling of ammonia, and this facility actually that's very specific to this country, at least for India. We at Paradip are storing the largest amount of ammonia, not only within IFCO, but also the other fertilizer industry here in Paradip. So altogether, it is nearly 1 lakh tons of ammonia being stored and handled by us. And that's why the target for today's discussions will be more a case study of our ammonia storage and handling processes. Just to brief you, ammonia, actually why ammonia is required to be stored in such a large quantity when it is harmful and not friendly for the population. The reason is that we need to produce the fertilizers for the food security of the country. And when it's a matter of food security, our plants, our crops, they require ammonia as nitrogen, as a major nutrient. And for that reason, there are various types of fertilizers are being produced in the country, which includes urea, NPK, NP, DAP, means nitrogenous and phosphatic fertilizers. And for that, we have the 5 manufacturing units in the country, and every unit stores ammonia. And obviously, because of the requirement of the nitrogen to such a huge quantum, because we are the agriculture-based country, and the need for the fertilizers by the farmers is also to that extent. We have to have these facilities to produce ammonia-based fertilizers in the country. So we have 5 units across the country, 2 in Gujarat, 2 in Uttar Pradesh, and 1 here where I am heading, that's in Odisha, the Paradip unit. The Paradip unit is the world's largest fertilizer complex, where we are having the phosphoric acid plant of 2650 tons of capacity, which is the basic input for the production of phosphatic fertilizers. Just to brief, the sulfur is used to produce sulfuric acid. We are operating an integrated acid cum fertilizer manufacturing complex, where we produce sulfuric acid by burning sulfur. We produce phosphoric acid by utilizing rock phosphate reacting with sulfuric acid, and ultimately the phosphoric acid, sulfuric acid, and ammonia all together produce DAP and NP. And in case of NPK, we add muriate of potash and DAP plants, and ultimately the required fertilizers are produced. So in the process of DAP, NP, and NPK, we require ammonia to be reacted with phosphoric acid, so that ultimately the ammonia-based fertilizers are produced in our plants. As far as the raw material inventory is concerned, while the major is the ammonia, where in a year we are consuming about 400,000 metric tons of ammonia, and this is being imported from various countries. No doubt nowadays, because of the Ukraine and Russia war, the major, that's out of 4 lakh metric tons, 3 lakh metric tons we used to import from Russia and Ukraine. And unfortunately, now this has, because of the force measures, stopped, and it's going to be the challenge for not only IFCO, but the entire fertilizer community in the country, that how to manage the availability of ammonia to produce the fertilizers. Disasters has been very well explained by Dr. Pradhan, so I'll not go much into the details because the time is also very short. I will just proceed towards the issues measure faced by the industries and where we can contribute to prevent the disasters. 2 types of disasters are always present before us. That's natural disasters and the other disasters which are not natural, caused by nature or by the act of God. In case of the disasters which are because of the natural calamities, maybe the floods, tsunami, landslides, even cyclones, or sometimes the lightnings, we understand that these are the major challenges before the industries, and this need to be tackled. And for that, we need the support of not only within the industry, but outside the industry under offsite emergency plans, which are very well documented, and the responsibilities of each and every stakeholders are well defined. But in case of the hazardous material spills or chemical accidents leading because of the toxic leakages or explosions or fire taking place within the industry, and there the role of industry becomes very vital. A few disasters were already indicated by Dr. Pradhan in his speech. That was one of the worst in the tragedy in our country. I would say that on 3rd of December, 2nd December night, 1984, the methyl isocyanate leakage in Bhopal's Union Carbide plant, and that created a big tragedy for all of us. And very recently, on 7th of May 2020, we had that Vijaya plant, one of the plants where the styrene gas was leaked and caused a lot of trouble to the population, including a few tragedies or fatalities. When the disaster management cycle is to be read, it's always there that the response towards the disaster or recovery and then mitigation and the preparedness of the industry here, I'm always giving more thrust within IFCO, that how are we prepared that the disaster should not occur, and if at all it takes place, then how to handle it. So if I talk about the chemical industry's overview for a country, it corresponds to about 3% GDP contribution. And 13 to 14% of the chemicals are being exported from a country, and we are also importing around 8 to 9% of the total imports in terms of chemicals. The chemical disaster has already been discussed by Dr. Pradhan in detail, so I'll not go much into these details. But the one major point or this slide I wish to present before you is that the process and the safety system, if that system fails, then obviously the resultant will be the chemical disasters. Natural calamities can also cause the disaster, which may lead to the chemical disaster because of the storage of large quantities of chemicals. The technical and the design errors. Now, these are the vulnerable things which need to be ensured, because if we look at the statistics of the disasters or the kind of major accidents which have taken place within the country or within the world, we find that the technical design errors and the human errors, the people who are responsible for handling those units, the capacity, their competence, their knowledge, their experience, and if they commit the errors, and then these two contribute the largest, I think the contribution is from these technical design errors and the human errors in the disasters. So where I would like to inform you about the ammonia storage and handling facilities in perspective of the disaster management. First, let me introduce you about the ammonia gas, because many of you may not be knowing. But ammonia is a liquid in the form of liquid at minus 33 degrees Celsius, and normally it remains at atmospheric pressure at minus 33 degrees Celsius, and it is being stored in the form of a liquid into the atmospheric storage tanks normally in our fertilizer plants, but at times we are also storing in some of the fertilizer plants in a pressurized liquid or a vapor. Normally, we find that the explosivity of ammonia ranges in case if it is having a lower to mid upper 16 to 25% concentration, and then only it is in explosive conditions. Its corrosivity is very, very less. It's very friendly to the metals, and that's a good part of ammonia. The effects of ammonia, if the leakage of ammonia takes place and if it is available within the range of 25 ppm, then there is not at all an issue for the people who are working in and around the ammonia installations. But as soon as it crosses 35 ppm and up to 100 ppm, that's called the short-term exposure limits. And here we have to reduce the exposure of the people working within the plant to be within less than 15 minutes. But when we cross the limits of ammonia presence beyond 100 up to 5,000 ppm, there are various effects on the human as well as the animals. And this can lead to a major concern for the population or for the residents who are within the township of the plant, or maybe the nearby villages where the effects of ammonia will be very dangerous. The hazard controls methodologies are already discussed, but let me tell you that the elimination of the hazard is the best way of doing or coming out of the possible disasters. Very recently, IFCO has come out with one very innovative product that's called nanotechnology based fertilizer. It has already been it has started producing nano urea, which is also ammonia based fertilizer, as well as we are also going to have nano based DAP. So nano DAP fertilizer is also going to be manufactured in the country very soon. We have already installed one plant of nano urea manufacturing 2 lakh liters of bottles in one single plant. The consumption or requirement of ammonia goes down extensively if we have the nano-based fertilizer production technologies. And this is where the nano liquid fertilizers where the requirement of ammonia. See, if I take a case of ammonia requirement at IFCO's Paradip unit, and we are going to have one nano DAP plant here itself, producing 2 lakh liters of the nano DAP. The requirement will be for 10,000 tons of production of fertilizers of DAP in IFCO Paradip. We need about 1,500 tons of ammonia every day. But when we will have the similar capacity, which already we have invested, we have got the approvals of government, and the plant is likely to be installed within December 23, the requirement of ammonia per day will reduce from 1,500 tons to just 6 tons per day. And that's where the technology is going to help us to eliminate the requirement of the conventional fertilizers, but gradually we are switching over towards a better technology, nano-based technology, and we are going to substitute grossly the requirement of ammonia. Similarly, where it comes to the substitution, the material technology, actually there are a lot of new materials being invented and being available, so that if we switch over to the latest technology from time to time, then also we can reduce the hazards or possible disasters. The engineering controls, as been very rightly said by Dr. Pradhan also in his speech, that the automation and the interlocks, these are very useful, but at the same time, the reliability of automation and reliability of the interlocks, that's also very critical. And for that reason, we have to be, the industries like us, we have to be very cautious with respect to utilizing the automation processes, automation in the processes, and ensuring the reliability of the automations. Obviously, the human errors, that is also one of the reasons has been normally found, and having proper SOPs in place, safe and standard operating procedures, if they are at place, and the proper work instructions are well defined, and better administrative controls are executed, I'm sure the possibilities of the human errors will be reduced if we employ the rightly qualified and experienced professionals. And obviously, the last but very important, that is the utilization of the PPEs to reduce the hazard controls within the plant. We are importing ammonia from outside the country because our country does not have the required, we cannot fulfill within the availability of ammonia within the country, and that's why we have to get it through ships in the form of cryogenic vessels, and we import from various resources. And these ammonia ships are unloaded at our berth, that's the jetty, and from there it is transported to the plant through pipelines. These pipelines, they are designed for the pressure of 22.5 kg per cm square, but we never allow the discharge pressure of the pumps more than 4 kg per cm square, and that corresponds to the facility of unloading nearly 1,000 tons per hour, the ammonia quantity from the vessel to our ammonia storage tanks. These are the pipelines which are used for transporting ammonia from the jetty to the plant. The very important requirement is that the pipelines which are constructed for handling ammonia, they are all low temperature carbon steel pipelines, and these are fit for operating even up to -45 degrees Celsius, as against we are having ammonia to be handled at -33 degrees Celsius. These pipelines are very well insulated so that the heat ingress into the pipelines, which may again lead to possible rise in pressures. So for that reasons, the insulations, the cold insulation over the pipelines, that's also one of the very important requirement. And these insulations are monitored using thermal imaging systems to ensure that the installations are very well in place, and they are good enough to take care of the ingress of the heat. So the surface temperature over the insulated pipelines is measured at regular intervals. Pressure relief valves and other devices, including the flexibility analysis of the loops or the pipelines which are utilized for the purpose of transporting ammonia, are very critical requirements, and these are being ensured by the installations in our industry. The most important is the design features. Actually, storing of ammonia like gas, it has got various options. We can store ammonia at ambient temperature. It doesn't require insulation, but in that case, it will have increased pressures within the tanks. If we have the conventional insulations and a pressure storage tanks, then we can go for the small quantities of ammonia from 2.5 tons to 150 metric tons. We can go for cylindrical vessels which are pressurized. There are also the spherical vessels, the spheres, Horton spheres, we usually call it, which are storing about 500 to 3,000 metric tons of ammonia. But these are also working under pressure, depending on the temperature of the liquid which is inside the sphere. The atmospheric storage of the ammonia, that is the most popular and most user-friendly, as well as on the disaster perspective. These are the least prone to disasters. And for that reason, the storage of atmospheric ammonia at atmospheric pressure is preferred. And that is normally found in the entire world. Now, when it comes to the atmospheric storage of the ammonia in the tanks, the design features are available as per the American Petroleum Institute API 620, that they define various methods and available designs for the tanks to store ammonia at minus 33 degrees Celsius. There can be single wall tanks where we have a single wall just to protect the ammonia to get spilled out, because that tank wall will be designed in such a way that it will handle the entire quantity of ammonia, the internal pressures as well. But if we have the external wall, this is a second design, where the outer wall will be utilized as a dike wall, I can say, and it will be used in case if there is any collapse of the internal shell or internal tank, it can hold the entire quantity of ammonia, but it will be exposed from the top, and that will lead to increased vaporization and may create problem for the population or the people who are handling it. Then there was another design developed as per API 620, where there was a concept of double wall tank with a common roof so that it always remains covered. But here the outer tank shell was not made of the LTCS, that's a low temperature carbon steel, and that leads to a problem of cracking whenever there is an inner tank gets any leakage. Then the idea came about utilizing the perlite insulation in the annular space with the inner tank and the outer tank. If we see, then in between the tanks, the filling of a perlite, that's a specialized insulation which will prevent the possibility of spillage or the increase in temperature or reduction in temperature rather of the outer shell wall. And ultimately API 620 has now very recent, not very recent, but about 2 decades ago, come with a technology that is a double wall, double integrity tanks. So in our country, majority of the tanks, I'll not say all, but majority of the ammonia storage tanks have been constructed according to the double wall, double integrity design concept, where the cup in tank, that cup will be holding the ammonia, and the outer shell that will be also equally competent and designed to handle ammonia in case if there is any failure or any natural disaster, because of the natural disaster or because of the high pressurization or failure of the systems, technical systems. In that case also, it will be taken care of by the outer tank. We have the 3 ammonia storage tanks at our site, which are holding 2 tanks of 20,000 tons each, and one is of 10,000 metric tons each. This is one number. So the total 3 tanks holding ammonia, and the normal operating pressure we maintain is just 300 to 400 millimeters of water column. This is a small video or animation about the construction of the ammonia storage tank, which is in use at our unit. So it contains pressure relieving devices. There are 5 relieving devices and 2 breather valves for in case if there is a negative temperature and the ammonia, when it gets filled up, the temperature whenever it increases, so it is taken care of by the pressure relieving devices where if there is an excess pressure. But before the pressure relieving devices come into operation, there are continuous operating screw compressors which take the ammonia vapors and convert them into the liquid and return back to the tank. I will explain about it. So the advantage of this design of double wall, double integrity is that the inner and outer tanks both are competent and capable of holding as a secondary container. The outer tank works and there won't be any possibility of spillage of ammonia, even if the tank which is holding ammonia gets any kind of a leakage or collapse. There are several automation instrumentations. I will not go into details of them, but there are the level gauges or there are the anchor straps. Actually, these are also provided to the inner tank so that those anchor straps which are fixed with the bottom of the inner tank ring with the foundation, so that there is no possibility of lifting of the tank, inner tank, because of the buoyancy of ammonia in case if it is going to the annular space. The instrumentation, whatever is being used, they are all of high reliability and they are verified at regular intervals for their performance. The safety valves are all pilot operated safety valves which ensure that in case of over pressurization, which is also a condition which can come in case if there is an error in the system or there may be the problem with the ammonia vaporization handling compressors. Even if that takes place, there is a provision that the pilot operated safety valves will take care of the over pressurization, and in that case it will divert the over pressurized or extra vapors whichever are generated in the tank to the flash stack. There are dependable and state-of-art alarms and interlocks, as well as the adherence to the safe operating procedures. This is a very critical requirement, and this is handled by the qualified and the experienced operators and the engineers looking after the ammonia storage area. There are 3 tiers of safety systems. The first is the refrigeration system, which takes care of the vaporization of ammonia happening within the tank. If the refrigeration system fails, then the next is the pressure relieving devices, where we have the high pressure relief valves, which will relieve the pressure. At times, it is also possible that to reduce the pressure or to maintain the pressure inside the tank, we are removing the vapors utilizing the compressors. But if that control of pressure is lost and a vacuum is created inside the tank, sometimes because of the system of refrigeration or maybe at times because of the high outlet quantities of ammonia going. In that case, if the vacuum is there inside the tank where it is designed for minus 50 millimeter of water column, but if it goes beyond that, there are vacuum breather valves which will open and will make sure that the pressure inside the tank, the vacuum inside the tank is maintained. There is a dedicated flash stack of 61 meter high. Actually, the ammonia is very light gas and it will always flow from, it will go onto the upward direction always with the wind. So the 61 meter high dedicated flash stack is provided so that in case if the system fails and the pressure relieving devices, they start operating, the operator can open a flash stack discharge from the ammonia storage utilizing the control room available access to the control valves, and the flash stack will light up and immediately the pressure inside the tank will be reduced. The requirement of the power sources is very, very critical for the ammonia installations, and for that we have the captive power generation units within the plant. And if required, we can, in case if our captive power unit during annual shutdowns, when we have the outages for about 15 to 20 days every year. So we depend on the power supply from the state grid. But if at all there is a problem with the state grid supply availability, in that case, we have our own diesel generator sets of the 2.5 megawatt capacity to handle the entire requirement of the ammonia area. Now, based on the design codes, the construction materials which are used for the construction of the ammonia, they are very much taken care of at the time of the construction of the tanks. The insulation over the tanks are also very specific, and nowadays the puff insulation, which is formed in situ, rather than utilizing the polystyrene insulation blocks, which were the practice in the past. So the in situ application of the puff insulation that helps to the reducing the possibility of ingress of the heat with better quality of insulating layers. The roof as well as the shell both are insulated. In case of ammonia storage tanks, the roof of the inner tank and the outer tank roofs, in some of the designs they are insulated, in some of the designs they are not insulated. There are suspended decks to cover the inner tanks, as well as there are various foam glass insulations below the inner tank, so that whatever ammonia is stored, it does not pass the negative temperature, the coolness of the ammonia that is at cryogenic temperature does not get passed to the foundation, as well as the heat of the earth that does not get transmitted to the ammonia storage tank shell. And for that, vapor barriers are provided. We have the tanks constructed in the year 99 and 2011. These tanks have been inspected once, and the tank the tanks commissioned in 1999 have been inspected once, and the tank which was commissioned in the year 2011 is yet to be inspected. I'll not go much into the details of the materials of constructions and all, but the one of the very important parameter, that is the wind velocity. The original concept of designing as per the wind velocity conditions, because there are seismic conditions, wind velocity conditions at different locations in the country. And according to that, the requirement of wind velocity considerations at the time of design were decided, and there is a specific IS codes. However, at Paradeep, we experienced at one time the wind velocity of 260 kilometers per hour that was experienced in the year 1999 cyclone. And for that reasons, whatever storage tanks designed now, or those storage tanks which were designed and installed in the year 2011 and 1999 have been verified for their suitability to withstand these wind loads. The various installations are there. I'll not go again into the details, but this is a flare stack where we are venting ammonia in case of very essential requirement, which is very rare. There are various instrumentation control, pressure transmitters, level measurement systems, and there are various temperature recorders and temperature indicating devices. All these controls, pressure and temperature controls, are controlled in a control room where there is a distributed control systems which can be operated while sitting in a control room are available. For the operation of various the screw compressors, again, the DCS system is capable to handle all the different screw compressors to take care of the generation of the ammonia vapors within the tank. They are converted to liquid utilizing this refrigeration system using 5 numbers of ammonia screw compressors. In addition to this, these safety relief valves, which are tested at regular intervals, this is very, very essential. And for that reason, the isolation valves are also available with every safety valve. The procedures that how to remove the safety valve, when to remove, how many can be removed at a time. So all those procedures are very well documented and are to be adopted for the purpose of conducting even the testing at regular intervals. Even the vacuum relief valves are also tested under specific conditions where we are not going to add the risk if we remove them for the purpose of testing. So that's also one of the very important aspects which are to be taken care of. There are various operational controls where the level inside the tanks are very crucial. Even the level can be generated in the outer tank because of any possible damage or kind of a discontinuity which might have created in the inner tank. So if there is a level of ammonia coming up into the outer tank in the annular space, that is also monitored very precisely with the level control systems. There are various ammonia sensors placed at different locations in the plants so that whenever there is any possibility of or any possible leakage before it becomes a major leakage, the ammonia sensors located in the ammonia storage area as well as inside the plants where we handle ammonia, those give the indications to the operators. There are various inspection strategies which takes care, and one of the major inspection strategy nowadays, that is a risk-based inspection strategy. And this is very essential. The thing is that it is generally thought that more number of inspections executed for a device or for a system will generate more comfort level for the operators to have that system is in place with required or adequate safety. But that is not true in case of inspection of the ammonia storage tanks. This is very vital parameter which is being considered, and the European Fertilizer Manufacturers Association, they have given away the guidelines for different countries. They have their guidelines which have been compiled by EFMA, and those I'll share with you. But this is only the reason that the possibility of the ingress of the oxygen, which otherwise takes place with every inspection interval, whenever we decommission the tank and allow it to come into the contact with the atmospheric air. Before that, it undergoes various decommissioning activities, including the purging with nitrogen and all. And ultimately, the tanks are made fit for conducting the test. But when we do this, when we recommission the tanks, again, the procedure of purging the tanks to remove the entrapped air inside the tank and then gradually allowing the ammonia to be entered into the tank, and then it gets immediately converted to the vapor form. So it has to be initially pre-cooled. So all these procedures requires utmost control of presence of air inside the tank. And that's why those possibilities of stress corrosion cracking, which can lead to rather it will be creating a problem on major hazard, because there will be the failure of the tank because of the stress corrosion cracking. And to reduce that failure probability, the risk-based inspection methodology that is being used to decide the intervals of inspection of ammonia storage tanks. There are various failure probabilities identified for the tanks, and accordingly, we also look at the consequences. Well, risk is what? Risk is nothing, but it's a combination or multiplication of probability and consequences. And based on that, we define or map the risk in case of ammonia storage. So if we look at the intervals of ammonia tanks, again, this is a general guideline, not the specific statutory requirement in that country, but this has been compiled in European Fertilizer Manufacturers Associations, one of the PDF manuals available on website, where different European countries follow their independent rules or kind of advisories to conduct the tests or inspections of the ammonia storage installations. It varies from 12 to 20 years. At times, at some locations, it is 8 to 10 years also. So in our case, in fertilizer plants, we normally undertake the inspection of the storage tanks at an interval of 15 years. But in case of storage or installations like in IFCO, we have switched over to risk-based inspection, where we conduct the entire cycles of operations of the tanks from the day of their commissioning. We also submit the documents which were prepared at the time of construction of the tanks, whether it was constructed with which materials, what were the welding procedure specifications, what were the procedural qualification records which were created. So all the informations, the cycles of operations, how many times the tanks have been depressurized or pressurized, how many times the ammonia has been loaded into the tank and it has been consumed in the plant and reduced to a certain level, which might lead to the high amount of vapors inside the tank. So all this data are kept available online with us, and this data are being shared with the consultants who are providing the services of risk-based inspection systems. So when we decommission the tank, we make sure that the tank is subjected to proper NDT and various inspection methodologies. I'd request Dr. Haldar, if kindly can you tell me that how much time I have to further discuss. Accordingly, I will make my speed on presentation.
Sir, maximum 10 minutes. Within that, you have to please.
Oh my God, 10 minutes, okay. So I will just brief my presentation very briefly. I will explain, and if required, I can share the presentation with Dr. Haldar so that it can be circulated to all those who need. So the tank inspection is very critical, and for that, not only the metallic shell, but the foundation of the tank, because we are handling the ammonia at cryogenic conditions. It's very, very essential for us. And for that, there are specific procedures or the inspection requirements have been laid down, which is conducted at the time when the tanks are decommissioned and subjected to inspection. So these are all the inspection activities we normally conduct at the time of decommission status of the tank, or even at the time of recommissioning, how it is to be conducted. That's also very well documented. So various photographs I had carried for conducting those visual examinations or magnetic particle testing or dye pattern testing or ultrasonic flaw detection, hardness testing, so all microstructure examination, radiography tests. So all these tests are conducted onto the tanks whenever they are available at appropriate intervals as per the risk-based inspection requirements. We carry out the inspections, which are normally the NDT, that's a non-destructive testing methods are utilized. There are many advanced and non-conventional, but they are available to the industries to utilize, like what was talked about by Dr. Singh from US also, and our Dr. Pradhan, that the latest or updated technology advancements, whatever are taking place in the world, they are to be utilized for the purpose of examination of our systems, integrity assessments of those systems. And for that, there are various methods such as slow FAC, LRUT, SRUT, pulse eddy current testing, low frequency electro. They are all available for the purpose of inspecting the pipelines or the storage tank bottoms, which are otherwise not available or accessible, but only one side is accessible. So how to inspect them? Earlier, the vacuum box testing was the only method. Now we have LFET methods available, which can undertake inspection of the storage tank bottoms using automated devices which are operated with crawlers. So the long range ultrasonic testing, I think I have only 10 minutes, so I'll not go much into the details, but there are various methods of testing these pipelines. And this is one of the method which we use as the long range ultrasonic testing for conducting the testing of the ammonia carrying pipelines. So this is one of the installation, I think in the year 2016, we got it conducted for our ammonia carrying pipelines. There are some short range ultrasonic testing that's also done for the annular rings of the tank shells. Also for the pipings where we have the supports. Now these are the very vulnerable locations. It's also very important for the industry to know that what are the possible damages which can take place, and also how to identify those damages in advance. So for that reason, the locations where the supports are provided to the tanks, and these are very vulnerable locations for possible damage and cracking. And for that reason, the short-range ultrasonic testing techniques utilizing the angle beam probes, they can help us to detect such defects which may be coming up into the systems. There are pulse eddy current testing systems. These are used for under the insulation if we have, because normally the installations of ammonia, which are at cryogenic service, this is also true for LNG and all. So where we have the insulating layers on top of the pipelines or on the tank. So how to inspect them without damaging that insulation? That is also one of the very critical requirement of technology, and where this pulse eddy current testing systems, they are available now, where without damaging the insulation over the tank shell or onto the pipeline, we can conduct the examination of the pipeline metal, whether it has got any corrosion losses or not, or if there are any localized defects which might have developed because of any reasons. There are pulse eddy current testing and other methods, so I'll not go much into the details, but these latest technology instrumentation now available are being implemented by the industries, not only IFCO, but there are many industries now they have switched over to utilizing such techniques for the purpose of inspection. So these are some of the pictures of our people conducting the pulse eddy current testing onto the pipelines. So there are the various results of those tests. Then there are saturated low frequency eddy current testing, which is normally done for the remaining wall thickness measurements. And this is also very important technique, which is used for the floor scanning into the tanks. The other method is slow FAC, and the second is LFET. These two methods are equally good and are suitable for conducting the tests on the floors or the tank bottom plates for the detection of any possible damages underneath. Exposed to the surface are very exposed to the eyes can be very easily accessed and assessed, but those which are underneath, those surfaces can also be very easily examined utilizing these techniques. Infrared thermography, as I told you before, that this is also very widely used, and even nowadays we are utilizing the drones, which are equipped with thermal imaging sensors. And recently there is a very good change in the permissions on utilizing the drones for the purpose of industrial installations. So that has helped us a lot, and we are switching over to the drone technology for conducting infrared thermography surveys of our installations. So they are all some pictures of the tanks, not on ammonia storage tank, but this is for the sulfuric acid tanks. But we conduct the ammonia tanks also the thermography surveys to know the condition of the low temperature insulation. That's a puff insulation. If there is any voids into it or any cracks in the insulation, those can be easily detected by measuring the temperature of the outer aluminum cladding onto the insulation. The in-service robotic inspections have also now come, these are available. So whenever we decommission the tank, or those tanks where we do not have the insulations from the outside, so we can conduct the inspection or utilizing the robotic devices which move on the wall of the tank. But very recently, this is a very, very special test. We have not yet utilized it, but we are planning and we are in discussions with this Denmark-based one of the companies. It has inherent possibilities of risk, but still this is one of the best technology which is considered in Denmark, and they have started utilizing in 1 or 2 installations. So we are working with them where the robot-based inspection technique, where the ammonia atmosphere inside the liquid ammonia, the robotic device can be immersed and it can go inside the tank. It will travel across the entire tank inner wall without any problem, and it will transmit the data on its integrity in terms of ultrasonic thickness values as well as the flaw detection values in case of weld joints. And this data can be utilized to decide the integrity level of the tank when it is scanned utilizing these ASTs. This is the AST device. There are certain other techniques. There's a phased array ultrasonic technique. There's a time of diffraction technique. So all these techniques are very spatial and very latest, and these are being used in industries, not only for the ammonia storage tanks, but for high pressure pipelines and other ammonia pipelines services. We utilize these techniques. And this gives us the level of confidence that the equipment or the installations within the industry, because it's a responsibility of the industry, and probably if it's not wrong, that the knowledge of the equipment or knowledge of the fluid, whether it's a toxic fluid or flammable fluid, that has to be available with the industry who is holding it, and we hold that responsibility of ensuring that these fluids are handled properly. The handling units are examined properly, assessed properly, their integrity assessments are done in a proper way so that their risk of any emergencies or a kind of disasters, they are reduced to the greatest extent possible. For the emergency preparedness, otherwise also it may be there are certain natural calamities or war-like situations where it may go beyond the capability of the industry to hold those leakages or those scenarios where the exposure of ammonia, which may lead to the other populations, or it goes beyond the control or beyond the on-site emergency control measures. So in that case, the preparedness of the industry is very, very essential. And for that reason, I am very proud to say that in Odisha, for this off-site emergency plan, our disaster management authority in the state, as well as the Directorate of Factories and Boilers, jointly have engaged. They had engaged the Disaster Management Institute, Opal, and they have worked out the off-site emergency plan for the district of Jagatsinghpur, where our major accident hazard units, like us, there are 9 major accident hazard units. They are situated in this district, and for that reason, we are the first to have this kind of disaster management risk assessment for the purpose of off-site emergency plans conducted for the district. So we lie into the moderate risk in zone 3 for the seismic zones. For the cyclonic zones, when velocity, I told you that we have experienced the tune of, we are in the zone of 200 kilometer per hour speed, that's 55 meter per second wind speed. But we had experienced 260 kilometer per hour in the past. And for that reason, all our new installations, as well as the past installations, are examined or assessed for the integrity to 260 kilometers per hour. On-site and off-site emergency plans are very well available with the industry. Our emergency command structures are defined, and the local as well as district crisis groups. So whenever we have the opportunities and the district crisis group meetings are conducted as per the statute, so we all industries get an opportunity to interact and participate, so that every day we get stronger and stronger in handling any possible disasters because of the handling of any toxic or flammable gases. Our off-site emergency management plant of the district, this is a picture of that. And there are various dispersal modules or modelings done by DMI Bhopal. And accordingly, we have also understood that looking at our location of the factory of IFCO, that within the range of 9.6 kilometers, in case of there is a catastrophic failure of the tank, then how much population will be there, what is to be done for that population, and how to ensure that this population is evacuated, what will be the routes for evacuation. So for that reason, the district crisis group, when we have the meetings, when we conduct the off-site emergency, off-site mock drills. So in those mock drills, the local administration authorities are also participating, and they understand the requirements of the industries to execute this kind of possible evacuation requirements. So various scenarios are considered for the purpose of assessing the dispersion modeling and accordingly the possible risk to the population that is assessed. One point was very much discussed about the population in and around the factories which are handling such difficult to control or risk prone fluids or liquids. So there I say that I have the experience, I've felt it. When the industries are allowed to be installed or allowed to be commissioned, at that point of time, the location of the industries are not much populated. But as the time comes when the availability of the business opportunities and employment opportunities that make those areas densely populated, and later on they create the risk for that population. So various emergency response structures and sorry, I don't have the habit of speaking long. So the emergency response structures and responsibilities are well defined, and these are followed by independent controllers who are already identified, earmarked for our industry, and they are being taken care of. The auxiliary team leaders, when it's a matter of communicating the requirements of the industry in case of any hazard or any beyond the on-site conditions, if we are reaching the off-site conditions, then the auxiliary team leaders are normally from personnel and administration areas who are more in handling the communication protocols with the concerned authorities. They are trained for that. The role of individual key persons, the emergency sirens, how they will blow, what should be the the siren pattern in case of fire, in case of toxic gas release. These are very well defined and being explained to the nearby populations so that they understand that what has happened before our information reaches to them from concerned authorities and the personnel. There are various smoke detection systems and facilities are available which pass on the message not only to the area specific operators but also the fire control rooms. Various on-site and off-site mock drills which are also conducted from time to time, and it's very, very prestigious moment for me to tell that the management, the government, the machinery management, the authority management is happening so beautifully that the requirement of the on-site or off-site emergency conditions management by the industries is being monitored from all the levels, starting from disaster management authority, directorate of factory boilers, all the collectorate level or the emergency officers of the districts. So from all the levels, the awareness is there. From the industries, the awareness is there, and definitely this law imposing authorities, when they are strict, when the industries are very well aware of the risk involved, I think we can mitigate and minimize the possibility of any disaster. So they are all mutual aid scheme also was discussed. So we have this mutual aid scheme with our nearby major accident hazard industries like Indian Oil, Paradip Port and Paradip Phosphates Limited. So we do take care of each other. We do take community awareness programs so that the community, not only the people in the village panchayats and other areas, but also the school children, even the nearby industries. We also have directions from the state regulatory authorities that we have to have adoption of the safety buddies in the form of small industries who are working in and around, and they are handling the chemicals like what we handle. So we do take care of them. We explain them how to handle those liquids because they do not have sometimes the required facilities available at a time of need. And we do provide them those assistance. And for that reason, even we have a small emergency response center established for the district first in Odisha, where we have this facility of communication between the small industries and the major accident hazard industries, where we are equipped with handling the possible damages to the people or population because of the various liquids. So here I end my presentation. Thank you very much once again, Dr. Haldar and Dr. Pradhan, for allowing me to speak onto this occasion. Thank you very much.
Thank you, sir. Very, very elaborative discussion regarding the tank safety and precautionary measure and what are the steps to be taken inside the tanks so that safety could be adopted. And even the mock drills you have given, mock drill sites are also shown, that all types of precautionary measure you have shown. That ammonia is a very poisonous gas, and in a very, very negative temperature, minus 33 degrees centigrade, it has to keep store, and all precautionary measure you have adopted. Even tank design in the top, roof, inside, all those things, each pros and cons you have highlighted. Even 3-tier safety system, the safety should be the first and foremost thing what is required, and for the hazards to avoid. And you have highlighted all those things, and plenty of things you are there. I know that within the short span of time you could not unfold your hands properly, but a lot of things you have given for the, especially for the safety point of view and emergency preparedness, all the things you have highlighted. Now we are very much thankful. Now, sir, only one question is raised by our participant. That is, I will tell the name also. Dr. Damodar Panda. He is active participant. Time to time he is raised the question. He asked politely that, sir, how to keep ammonia in safe without leakage in case of damages to plant due to cyclonic storm or tsunami impact? Shall I read second time, sir?
No, I understand. The question is very clear that how to remain safe in case of cyclonic conditions or any natural calamities. And for that,
Yes.
I can only tell one thing, that the installations which are storing ammonia are to be designed for the purpose and designed for such possible natural calamities based on the experience. The IS standards, the codes are being reviewed again and again, and the installations which are already there handling such fluids like ammonia are to be subjected to integrity assessments at the time of at regular intervals, and all those revised requirements are to be taken care of. That's the only way we can have the confidence on the status of or integrity of the equipment which are handling ammonia.
Yes, sir. From your experience, life, and the needed precaution, you have given the appropriate answer. Thank you. Thank you very much, sir. Only that much question was there. Now, thankful. I'm thankful to you, sir, because within the short span of time you have covered, you have tried to cover, and you have whatever in your mind you have tried to explain now. So next is that vote of thanks I have to put. So, so behind this program, our executive director, Sri Taj Hassan, IPS, he is always there to fulfill our dream for the stakeholder. So for that, a big thanks to him. Now next is our learned speakers, that Dr. Pradhan and Dr. Patel, both are there. From their experience life, they have shared a wonderful experience and precautionary measure for the students. So I put my heartfelt thanks to both the speakers. They have shared, they might have busy, but still then they have given the time to NIDM and our participant to share the knowledge. So it is a heartfelt thanks to you, sir, to both of you. Next is our Professor Surya Prakash. Always he's behind us to make the program successful, and always he himself put the time to how and which way it has to be made success, and it has to share the knowledge for the participant and our panelists. So I am very much thankful to you, sir. Now, next is our panelist. He is also with us. A lot of some panelists, they have joined. So I put my big thanks to them also. Now the participants since morning, of course, initially some problem was there, but thereafter he has joined slowly, and they have made our this webinar success. So I put my great thanks to all the participants. So our IT teams and all other supports are there. For that, we make the this webinar successful. I put my thanks to them also. Now, overall, it is a great support. I have seen that some learned participants are there. So always they are supporting us that it is appropriate and as per the objective. So Professor Manavalan, he is from Kerala. Always he supports us, and some other professors are also there. So they are always commenting that it is the appropriate thing. So I am thankful to them also. Now with this, I put my end for this today's webinar here. Now a big thanks to them for those names I have forgotten to bring front, but their activeness is there. So I put my big thanks to them. Now overall, I'll close here. I will leave the event here because this slot will be booked by some other our these faculties. Now, thank you very much to all of you.
Thank you, sir.
Thank you,
Okay.
sir. Thank you very much.
Okay, namaskar.
Namaskar.